This webcast continues in Worksheet 2C, where we're talking about velocity and speed, and we're looking at question 2. So in question 2, they're giving us 6 scenarios, and they're asking us to rank them first based on velocity, going from most positive velocity to most negative, and then we're going to rank these scenarios based on average speed, from greatest to smallest average speed. Okay, so we've got 6 scenarios, and let's just look at these. In order to find velocity, I have to know the displacement. And so when I look at scenario A, the object is staying at a position of 25 meters for the entire 10 seconds. So it's not going anywhere, right? If I tried to find the displacement, which is the final position, minus the initial position, it's the same. So the velocity is 0 meters per second, and the speed is 0 meters per second in this case, right? The object is not moving. I think the same is true in scenario B. Now it's at a different position, right? Here it's at a position of 5 meters, whereas in scenario A it was at a position of 25 meters. But when you have a position versus time graph that is a horizontal line, the position is not changing, and so the object is not moving. So once again, we have a scenario where the velocity is 0 and the speed is 0. Okay, so that's looking pretty simple. But now let's look at scenario C. So this object is moving. It's moving at a constant speed in this positive direction, and I know that because the position versus time graph is linear and it has a positive slope. Okay, so the displacement here is the final minus initial position. It ends up right at a position of 10. It started at a position of 0. So the displacement here was 10 meters. Actually, that's also the distance, right? Because in this scenario, the object is moving in one direction, and it's always the positive direction. So that means that the distance and displacement are the same. So velocity is displacement over time, which is that 10 meters, and it moved for 10 seconds, so we have a velocity of 1 meter per second, and in this case the speed, it's the same, right? Because distance is the same as displacement, so the speed is also 1 meter per second. Okay, let's go down to scenario D. Again, we have something moving at a constant speed in a positive direction. But here, it started at an initial position of 3 and moved to a final position of 10. So the displacement is 10 minus 3, which is 7 meters. The distance was also 7 meters because, again, this object is moving always in the same direction, which is the positive direction. So there were no changes in direction, and so distance and displacement were the same. So the velocity is 7 meters, and the elapsed time was 10 seconds, so it's 0.7 meters per second, and the speed is the same thing, 0.7 meters per second. Okay, so far we haven't had any situations where speed was different than velocity. Is speed always equal to velocity? Well, maybe not. Let's look at scenario E. What's different here? E, this object is moving at a constant velocity. I know that because the position versus time graph is linear. But this graph has a negative slope. That means the object was moving in the negative direction. So now speed and displacement will have to be different, right? Remember that the displacement is a vector and it's the final minus initial position, and so it could be negative. The sign of the displacement tells us the direction that the object moved. Here, the object ends up at a final position of 0 and started at a final position of 15. So the displacement is negative 15 meters, but the distance is the sum of the absolute values of the displacements. So it's going to be a positive 15 meters. So the velocity is the displacement, which is negative 15 meters that were moved in 10 seconds. So it's a negative 1.5 meters per second. But the speed is the distance over the elapsed time. So that's going to be positive. A positive 1.5 meters per second. So here we do start to see some differences between velocity and speed. And let's look at the final scenario, scenario F. So here we have a position versus time graph where it is not a single line. First, we have a linear trend in the positive direction, so the object was moving in the positive direction, and then we have a line with a negative slope. So it turned around here and started moving back in the negative direction. It changed directions in the middle of this trip. So the displacement here is the final minus initial position. So it ends up here at position 5. It started at position 0. And so we have a displacement of 5 meters. After the whole trip, it has moved in the positive direction by 5 meters. So the velocity is that displacement divided by the elapsed time. 5 meters was moved in 10 seconds, so the velocity is 0.5 meters per second. But now we need to find the distance if we're going to find the speed. So the distance is the sum of the absolute values of the individual displacements for each part of the trip. So for the first part of the trip, it moved from 0 to 10. In the second part of the trip, it moved from 10 to 5. In other words, we moved 10 meters in the positive direction and then moved 5 meters in the negative direction, so the displacement was 15 meters. Therefore, the speed is the displacement divided by time, is that 15 meters divided by 10 seconds, or 1.5 meters per second. So again, we had a situation where the velocity and speed are different. So if an object moves in the negative direction, or if there are changes in direction as the object moves, those are the scenarios where velocity and speed will be different. Okay, so now we could rank these. So first I will rank them based on from most positive to most negative velocity. And I only had one negative velocity, so I know that goes over here. That was scenario E. The most positive velocity was the, let's see here. I had 1 and I had 0.7 and 0.5, so it looks like C is the most positive. 0.7 was next, 0.5. And A and B were tied, so it doesn't really matter the order that we list those in. So that would be my ranking in terms of velocity, going from most positive to most negative. Now let's rank by average speed, going from greatest to smallest. So the greatest speed, let's see, look, I had 2, scenario E and F had average speeds of 1.5. So those were tied for the greatest, so it doesn't really matter the order that we list them. And then I had a 1 meter per second in scenario C and a 0.7 meters per second in scenario D, and then A and B were tied. They both had a speed of 0 meters per second.